In this example, we're asked to find the inverse of this function and then graph both this and its inverse on the same graph. So one of the things we wonder is, first of all, does this have an inverse? And how do we determine that? Well, for an inverse, we look to see if it passes the horizontal line test. So what we need to do first is to plot this function on this graph. So we see that our y-intercept is 6. So we go up 6. 1, 2, 3, 4, 5, 6, and put a dot right there. And we now see that our slope, which is the coefficient of our x term, is a negative 3 over 1. So we go over 1 and up 3. 1, 2, 3. Put a dot there. We can also go over 1 this way and down 3. Over this way and down 3. So there is this particular graph, and we'll just sketch it in now. So it looks like so. Now, the vertical line test is an imaginary vertical line that moves across the graph this way. Does this imaginary line intersect this graph in more than one place as it passes across the face of it? And it doesn't. So this is a function. Now the vertical line test is the one we just did. This is the horizontal test, where we bring this line down. An imaginary line that's horizontal. Does it intersect the graph in more than one place? And no. So it passes the horizontal line test and therefore is a one-to-one relation, and then does have an inverse. Now there is a recipe to find the inverse of something, and for this we'll go to this one here. How do you find the inverse? Well, remember, the function symbol can always be replaced with a y. Now, to find the inverse, we replace the x with the y and switch them around. So our x term will come out here. Our y term will replace the x, and we just have the 6 there. So for step 1, to find the inverse function, we replace the function symbol with a y, and then we switch the y and the x around. So that's what we've done. Now we solve for y, and perhaps the easiest way is to take this negative 3y, bring it over to this side now, and that becomes a positive 3y. Bring our x over to this side, this becomes a negative x, and we still have our 6 there. Now to solve for y, we divide everything by 3, this by 3, this by 3, and this by 3. And we now get y equals a negative 1/3 x plus 2. Remember, there's a 1 there, and I'm just separating that a little and doing this division. Now our final step, and I could just erase this. We replace this y that is now the inverse function with the inverse function notation. And we now have it in inverse form. Now we are asked to graph this, so our y-intercept will be 2, and our slope is 1/3. So let's put that in there now. Get back to our other graph. 2 right there, and a negative 1/3. So I'm going to go over 3, 1, 2, 3, and up 1. So I'm going to go down over 3, down over 3. So now in blue, I have my inverse function. And it looks like so. You can probably see that this angle and this angle are the same. And if I were to fold this along my axis of symmetry, which has the equation y equals x, which is right here, we see we have symmetry between the original function and its inverse. And this is the graph of it.